Hi all, welcome to the session on statistics for data science. So in this session, we are going to see about the standard deviation. So we have already seen the other measures for central tendency, but now this is the measure of dispersion. So any data, so any data that we have got, and we have to understand how far it is distributed. Okay, what is the variation of your data? So you can start with a simple calculation like finding out the range. Okay, so range is nothing but what is the distance between your highest value and the lowest value. Okay, so let's say for an example, you have 2, 3, 9, 10, and let's say this is 15. Okay, so what is the distance? So what is the measure of dispersion? So the first one is range. So your highest point is 15 minus 2, which is equivalent to your 13. Okay, so this is the simple calculation. But here one disadvantage is that we are not considering the other points, okay, other data points. See, for an example, let's say if this is also like this, let's say 2, 2, 2, 2, and the last point is 15. So for this kind of data also you're going to get 13, right? Even for this data is also you're going to get 13, but this data is also you're going to get 13. So that's the difference between your range and the standard deviation. See, for the range, you will be only consider the lowest value and the highest value. But for the standard deviation, each and every value is involved in the formula. Hence, the standard deviation is the most reliable method for us to understand how far your data points are distributed. So let's see the practical way of calculating your standard deviation. So again, standard deviation is nothing but a measure to find out how far your data is distributed. So let's say if you draw a normal distribution plot, so you will get a curve like this, assuming that your data is normally distributed. Okay, so if you see like this, see, this is the distance. So how far your data is distributed. Let's say starting from 2 to 15. Okay. So you see, this is the lowest point and this is the highest point. So how far your data is distributed. So this standard deviation is a measure for us to understand the deviation. So, but let's consider your data points. So let's assume random information. And the last one is 15. So let's try to find out the Excel formula, standard deviation for your population. So the answer is 4.92. But let's turn this 15 to 150. You see, the score is getting increased. So we have to understand why, okay, and how the score is increased. But just to again, for the the standard deviation part, higher the score, wider the distribution. Okay, so if you get the small score, which means like your data points are clustered. So if you get the higher score, which means the data is widely distributed. See, if you can see 2 and 150. Minimum point is 2, maximum is 150. Again, when you calculate range, okay, so range to 150 to 150 minus 2 is your answer is 148. But if every point is like 2, you will again get the same answer. But here, if you see, the standard deviation is changing. So, but let's say your range is going to be 148 regardless of the other points. So because it's only considering the lowest point and the highest point. But whereas the standard deviation, see each and every point. Now, even if I change 1 point, you will see the change in the standard deviation. So let's see the practical way of calculating, okay, calculation of your standard deviation.